Hi all, Mads Barnkop from Kaizer Electronics here. Today we're taking a look at this Philips Practix X-ray system. It is a rather mobile system, except for of course the weight. Consists of a main power unit here, where you can adjust the milliamps, kilovolts, timer, etc. And that feeds a inverter which outputs power to the high voltage transformer located inside the head here, where we also have the X-ray tube. At the bottom we have the collimator which shapes the beam and all the inserts of aluminum plates and such. Along is also the complete cable set, so have some nice big old school aluminum connectors here. Trigger button, double actuated. Some very nice old school stuff. So I have no intentions of doing my own X-ray shop, so I'm going to take it apart, keep the high voltage gear of it, and of course this nice controller box here will probably make a nice demonstration unit on high voltage experiments. From the sticker on it, we can see this was last calibrated in 1999, where it was mostly thrown out some 2 to 4 years later. So it has not been in service for something like 15 years. Let's run through the system. The X-ray head and tank has started leaking oil. That's pretty bad. So it has been leaking oil down through the inverter box over here. So let's take a look at that. It features a voltmeter, a milliamp meter, what is presumably a status lamp. We have a milliamp adjustment potentiometer here. We can set the kilovolt over here. There's a okay, that's some kind of voltage stepped switch. Then we have a timer. Goes from 0.04 seconds and up to 5 seconds of exposure time. And then there is a selector switch here that we can use small focal area or large focal area. The tube inside is a dual focal tube. I'm not sure what this means, maybe off, and yeah, some kind of speaker, or it's also down here. I doubt that's a speaker. That must be something else. But if we take a look at some websites I found with this system, we can see that the reason why it actually has feet underneath and also feet on the back here is because it's normally sitting on a trolley. So this is an old mobile system from the 1960s. So quite old. We expect to find maybe some old SCRs inside. I doubt it's tube technology, but we'll see. It could also be it's just mains driven, that is just simply switching on and off 400 volt AC up onto the head, and the whole high voltage power supply is just built in here. On the back we have a type shield, 220 volt, 50 Hertz, and it says it's the type XB7002/00. And it's the number, yeah, that's just serial number. Looks like the whole frame will have to come off here. On the connector side we have white plug, brown plug, small white plug. We have the 230 volt AC connection here and some kind of a lid here. Wonder what that is. Aha, fuses. Nice little service lid. Nice big ceramic DO0 fuse holders. Let's see what's rated. It's rated, no text there, I think 15 amp for that one. And another 15 amp for the other one here. Maybe it's actually D00 fuses. Oh well. Nonetheless, nice old ceramic fuse holders. They can burn red hot and it's not an issue. Now if we take a look at the X-ray head, we can see we have a brown plug here and we have two smaller plugs here. but there's not really any white plugs anywhere. And from the cable set here, there is a white set along with this one. This is a pretty thick cable. Ah, okay. Makes sense now. So the one here, that should be what connects to the head. Hopefully that fits. Yeah, that fits there. That goes to the collimator. That's probably for the light. And then over here we have the power connector that goes to here, and then we have the double actuated activation switch here, and then we have the small one. Oh, that must be the light. Okay, so this is light, this is control, this is power. Okay, so it all makes sense again. The collimator on the X-ray head has these sliders to adjust the beam width and length, and it has this weird timer. I'm a bit unsure what that's actually used for. And also some kind of indicator, 100. That could be the 100 kilovolt the tube is rated for. So if we look into the collimator here, we can see that using these sliders we can adjust the aperture of the X-ray image being, or the X-ray exposure. So you don't want to expose humans much more than you need. The back plate was just fastened by 6 screws, so let's see. Oh nice, what do we have here? We actually do have some vacuum tubes. Adjustable power resistors, some huge transformer, we have our fuse elements. And down here we seem to have this is potentiometers, so most likely for calibration. We have all our component strips sitting here. Some early diodes, very nice stuff here. So I guess having to dive deeper into this, we'll have to... there's not really any screws on the front or anything else, so maybe it's just this frame here and it kind of falls apart. Okay, it wasn't just that. Actually, that frame is going nowhere. But it's like the panels and the bottom panel here is all loose now. I wonder how this is actually put together. Ah, it's one of those lovely mysteries. This is quite a clever enclosure design. The only screws I had was fastened here at the back, and that is clearly holding all the cladding here. There's nothing on the front, but if I then pull this backwards, then it unlocks. It can just go past the back frame and you can pull it forward again. And all that held it in place was these 2 screws and then underneath the 2 frame parts. Very clever. So I assume we can do the same with the side and back panel. Just needs a little help. Ah yeah. And in the very nice old school style, this is just absolutely packed with electronics. From the side we can see the large on-off selector. It just rotates all the way around, selecting the mode you want, so you can actually go directly from off to small focal and over to the weird funnel thing and then to large focal point. At the bottom we have the voltage selector, and we see all the gray wires here along with these go up to the black transformer. This is also the voltage selection. We can see we also have some cam wheels sitting down here, making some selections on a switch behind it. So this would be the highest setting. And then we go lower, 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 and it switches over to the small focal point. So this is our large and small focal point selector. Small focal point does not need as much voltage and current. In the middle we have the voltage adjustment. So that's also the gray wires, and just seems to be, I guess, a multi-tap point selector on the transformer. Then over at the exposure timer we have a wheel of resistors into this multi-selector switch, which is quite a lot of steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 steps. And this is without a doubt what most of the circuitry at the back is all about. We have all the colored wires sitting here. We have some relays sitting over here. And if we take a look at our power circuit here, again, all the circuitry and the tube, that will have to do with the timing circuit. Now the X-ray head is leaking oil from this part. This is at least where it was wet, and this has been dripping out over a few years that it has been in my storage. So I think we can safely assume that it is no longer optimally filled with oil as it should be. And as I said in the start of the video, I have no intention of actually producing X-rays. That is just not part of my definition of a safe hobby. Despite having torn down X-ray heads before, and that is quite messy, I think we should try it anyways. We are now gazing down into the window of the X-ray tube itself. The collimator is taken apart. The whole arm assembly here, quite clever. Again, just sitting with a simple tightening band. Comes in two parts. And the same bracket that is used to mount this to the arm is also the one holding it together. And on the inside, we actually have here some date marks. Diagnostic type protective tube housing meets ICRP recommendations 1959. So this is the medical quality stamp that this upholds to the standards of the time. I think there was another stamp somewhere. Was that inside this one? Okay, we have some kind of degree wheel here on the side. I think it was here. Ah yeah, the marking plate. Here we have it. The type XB 1020, 100 kilovolt. It has built-in 2 millimeters of aluminum filtering. And yeah, that's about that. I'm quite unsure why there's actually two marking plates here. If that has to do with the small and large focal point. Ah, there's some kind of symbol over here. Yes, this is some kind of... We have many errors, then one error going out, so that's some kind of filter symbol. And here we have the large square, which we saw is the large focal point. So small focal point is probably just from the voltage and current selector along with the collimator setting. There was 3 screws sitting on the inside, one end of the head here, and maybe I could see some wires. I expected another screw down here, but it's just wires I can see. It's like, oh. Okay, that's quite a lot more technique inside than expected. So there is actually a local actuator to turn it on. Most like the safety features. Up here we have some more stuff. some kind of rotational switches maybe. That it has to be in a certain position to actually be able to produce X-rays, that you cannot point it like straight forward, that it has to point down. But again, there's some more stuff to take apart here. Clearly we have the tube sitting down here, because we have the window here. Up here we will have the transformer itself. This is quite weird. I'm pretty sure this is the high voltage transformer. And it had these two springs going down over this, and this appears to be all metal, so it's not like it's some kind of electrical connection. That seems to everything go through over here. No, this actually seems to be some kind of expansion chamber, that when this is used extensively, the transformer will heat up the oil, which will then expand, and that will have to go somewhere when it has to be an enclosed unit. So I think this is actually just an expansion chamber, and there's no way pulling that up because I'm of course pulling against a vacuum. So we will still have to find somewhere to poke a hole. And I'm also fearing now that getting this high voltage transformer to run outside of this could get a bit tricky. This is, okay, so this is maybe some kind of overheating switch. Well, that makes sense. That there's actually a switch sensing this, so the movement here can be when it's pushed too much out. That is clearly overheated as it has expanded too much, and it will have a thermal shut off that way. Actually quite clever, because then you don't need to measure at certain or many points in order to measure what is overheated, because all kind of heating would expand the oil, so this catches everything. We are now staring down into the oil. You can see it down here. And the whole relay thing here, which is actually burned here on the backside. Okay. There's probably a reason this was thrown out at some point. But the whole relay here is actually the focal point selector, that by rotating this mechanism, you can see down here that it has the small arm, that it can rotate the anode of the X-ray tube. So the next thing to do now is get rid of the oil. Well, I have been surprised before how much oil is actually inside an X-ray head, so I'm guessing 4 liters this time. We should see, and some plastic out on the work table, some cloth to absorb any spilled oil. So let's see how this goes. Golden oil from a golden age. Okay, there's quite a lot of dirt in that one. Once we start tipping the bottom and getting it shaking a bit, that's about it. Just around 2 liters. Of course, it would have to stand and drip and drain itself for quite a long while before I will try to pry that open. Transformer has been sitting upside down for a couple of hours now. I did a quick PCB test, and that is simply by taking a small bag of water and then drop a few drops of the oil into it. And if the oil floats, then it is not a PCB containing oil, as PCB oils are heavier than water. Now that test can only tell you if there is PCB present it cannot tell you the concentration. You can do some burn tests, but please only do that if you know what you're doing and you won't get to breathe the fumes from it. The best thing you can do is, of course, to buy a PCB oil testing kit to be 100% sure. But we'll wear some latex gloves and working gloves and try not to get oil anywhere else than where we want it. So there seems to be like 2 screws with golden spring wire sitting down here. And I would guess that once these are released, we can actually bring out the X-ray tube. Ah, okay, that's just spring-loaded. We actually didn't need to remove that. So let's just try to pull it out. It's most likely sitting in a socket of some kind. Yeah, okay. There it goes. Wow, look at that beauty. Okay, so the focal point change is actually shifting the cathode and not the anode. That's quite interesting. So let's just take a closer look at the tube here. We can look up into the cathode there, maybe. It's very hard to get on camera. But we can see the window for the X-ray there from the anode. And looking into it, I can see that there is quite a bit of wear on the anode plate there. It's marked 57403. And up here we have 62220. It doesn't seem to have any other markings. Opening it up further is most likely only to knock it open here. That's most likely solder it, and I have before just used a hammer and a chisel to get that knocked out. So I think I'll try that method one more time. Okay, so prying it open with hammer and chisel is not exactly pretty, but it gets the job done. So the big question is, can we get it out now that the chassis is a bit deformed? Hopefully there's not too much oil back. So we just like seems like we deformed the chassis quite a bit down here, so that's getting stuck there. Let's try one more time. It's mostly going nowhere. It was the actual side window for the X-ray output that was actually holding it in place. That little recessing thing here, that just went into the socket for the tube. So that was enough to hold it pretty good in place, despite just sitting with an O-ring. And here we have our assembly. It would have been nice to actually prepare to use some tools. Up here we have the high voltage connection from the high voltage transformer to the tube socket, and over here we have the cathode connections. We also have some shielding, grounded shielding around it. Now the filament or cathode transformer, we don't need that anymore. I'm actually just interested in this high voltage transformer here. Wow, look at that baby. So we would expect this to be midpoint grounded. As we can see, it also has 2 windings. Over here we have some of the gray wires, and we see most of the gray wires actually going into the primary of the transformer here. So from here on, it's quite a bit of cleaning and not getting oil everywhere. So I will turn off the camera. I hope you enjoyed this teardown, and I hope you learned something about X-ray heads, high voltage transformers, and 1960s technology on some medical devices. So if you really enjoyed this video, please share it with your friends or any social media groups with similar interests that you might be part of that I am not. So until next time, see ya!